Welcome. Today we're going to be taking a look at the integral zero theorem and what it does for us. So one of the things that we're doing in this video is we're trying to factor this polynomial into first degree factors. Now this happens to be a third degree polynomial because the biggest exponent for the variable is a 3. That's why it's third degree. So when I factor this into first degree polynomials, the biggest exponent will be a 1 for the variable. So what I want to do is use synthetic division like we saw in an earlier video. That's where we have it set up like this. And we have to use values for a that are factors of our constant term. So for example, 2, 1. I could also use -2, -1. Any of those are factors of 2. So I'm going to try, I'm going to try, how about 2? The process, if you recall, is to put the coefficients of 1, -2, -1, and 2, and then we bring the first one down, multiply 2 times 1, put it under the next one. 2, add 0 times 2 is 0. Add -1 times 2 is -2. Add 0. If it's a factor, you're going to end with 0. If you get anything other than 0 in your last position, in your remainder spot, then it is not a factor. 2 being a factor means x minus opposite of the sign, 2, is the factor. That's the binomial factor. These, remember this is x squared, x, constant, remainder. That would be x squared minus 1. There's no x to the first term. At this point, this continues, x minus 2. And because I only have an exponent, biggest exponent of 2 for my variable, I'm going to factor this with one of the methods of factoring that we've learned earlier this year. And in this case, that's difference of 2 squares, x plus 1 and x minus 1. There is my factoring. Now, if I want to know the zeros of the function, and that is where the graph crosses the x-axis. So if I had a graph and I drew this graph, I don't remember exactly what it looks like, but it's something like this. It crosses the x-axis at 3 particular points, at -1, at +1, and at +2. That's what the zeros represent. So if I take each of these parentheses and set it equal to 0, and solve the equation, x would equal 2, x equals -1, x equals +1. Those are my zeros. You could also say zeros are x equals 2, -1, 1. That's another way to write it. Those are the zeros of the function. So I need 2 things here. I need the first degree factoring and what the zeros are. Now you're going to pick up quickly that you don't always have to write it out. You can see that this is going to come out to +2, -1, +1. And you can pick up on that fairly quickly, but you're always welcome to set them equal to 0 and solve. Here's our next example. In this one, you can try it on your own if you'd like, to see if you can find something that goes into 12 and gives no remainder. In this particular case, I think that it is, let's see, 2, 3, negative 17, 12. And I believe one of the numbers that we'll try is 1 and see how that works. Because it's probably best to pick numbers that are smaller than bigger. Don't start with 12 or negative 12. Start with things like 1, negative 1, 2, negative 2. Don't just jump to the big numbers. It just is faster to run through those and easier to eliminate options. So 2 times 1 is 2, 5, 5, negative 12, negative 12, 0. It worked. So x minus 1, remember the a value is opposite sign when we go to put it in. And then 2x squared plus 5x minus 12. Now if you recall from earlier, we did smiley face factoring on this before. When you have a coefficient next to your x squared term, so I've got my x minus 1. And then we've got something that multiplies to 2 next to my x. The only options are 2 and 1, right? So 2, 1. I know I have to have a sign of a plus and a minus because my last term is negative. So I'm going to put, let's see, I think I need minus here, plus here. I think that works. And then a pair of numbers that multiply to 12 going here and here. And then I'm going to multiply these two, and add them to find my middle term. I believe 3 and 4 are what I want. That gets me negative 3x, positive 8x. You can see how that comes out to 5x, which is my middle term. And that's what I'm shooting for. So there is my, let me just do a little erasing here to get rid of some of this extra writing that's not needed. All right, so this is my factoring. The zeros, E, make an E, the zeros here are x equaling positive 1, x equaling negative 4, and then this one, x is going to equal 3 halves. If I wrote that out, 2x minus 3 equals 0 and solve it, you see I add 3 to both sides and divide both sides by 2, x equals 3 over 2. And there you have our 3 zeros and our 3 first degree polynomials. All right, let's take a look at another example. You can always pause this and try some of the work yourself before you start. Now in this one, in class, we tried this and I had everybody in the whole class, so 20 plus students, all trying the same example to see if they could get a 0. And we found 4 that work here out of the, what is that, 16 different options we have for 24, the positive options and the negative options. So let's try an example. Let's try negative 2 here. In fact, I'd like that to be a different color. Maybe just a little easier to see. All right. So if I were using this, I'd bring down the 1, 2 times, negative 2 times 1 is negative 2, negative 2, 0. Negative 2 times negative 2 is positive 2, add negative 13, multiply 26, add 36. I can see right away this is not going to work because when I multiply negative 2 times 36 and negative 72, that is not going to be 0. So sometimes you can notice by the time you get to here, the next to last one, it's just not going to work. So let's try a different value. How about we try, well, I guess we could try 2. positive 2 this time. So 1 times 2 is 2, add 2, I get 4, add negative 11, I get negative 22, add negative 12, I get negative 24, add 0. And there we have it. It came out to 0. Remember, you're adding straight down each time, multiplying by 2 to get the next value. Okay? All right, so that tells me that x minus 2 is one of my factors, and this tells me how to set up the rest of it. X to the third plus 2x squared minus 11x minus 12. Now, I don't have to use 24 as my final number. I only have to find factors of 12. Here's the problem. I can't just factor this the way it sits. I actually have to do that synthetic division again. Well, this time when I do my synthetic division, I'm using these numbers from here to here. The 0 has already been used, which is really these numbers. So I'm going to use, let's see, I'm going to use 1, 2, negative 11, negative 12. Let's put, how about we put 1 in here? Nope, negative 1. Negative 1. We'll use negative 1 this time. All right. Negative 1. 1. Negative 1. Negative 12. Positive 12. 0. Awesome. So I've got my x minus 2 from before, and now I've got x minus negative 1, which is plus 1. And then I've got this, which is x squared plus x minus 12. I have a little more work to do. I've got to factor this. And this factors into x plus, x minus, 12 multiples of 12 that differ by 1. 4 and 3 give me negative 1 in the middle. So now that is my factorization of it. My zeros, 2, negative 1, negative 4, and 3. And there you have it. Number 9, in this one, you're going to have something called multiplicity. Now, multiplicity is when a factor shows up more than once. So if I've got my 1, negative 6, 12, negative 8, let's try 2. 1 times 2 is 2, add negative 4, get negative 8, add 4, get positive 8, add 0. It worked. So I've got x minus 2, and then x squared minus 4x plus 4. This factors into x minus, pair of numbers multiply to 4, add to negative 4, 2, 2, where both of them are negative, and I've factored it. Well, look at this. We have a multiplicity where the thing shows up 3 times. So the m is 3 for the 0 of x equaling 2. And there's your factorization, the multiplicity 3 for x equaling 2. Finally, we have a problem like this where you are given the zeros and you're asked to write at least the factored version of the polynomial. This is a degree 4 polynomial. So really, we're working backwards here. Before we started with this and we worked to that. Now we're going to start with this and work backwards. So x minus 2. This one is x plus 2. This one is x plus 1. This one's the tricky one. Hi, I'll be right with you.
Okay.
This one, the denominator is the coefficient of x, and the numerator is what you're adding or subtracting, in this case minus 1. And there is the entire thing. Hope you understood it.